on that. Yeah. Thank you so much. Well, we're going to go ahead and get started. It's the top of the hour. Welcome in, everybody. My name is Aida Awad. I'm representing NAGT on this webinar. Today, we have a fantastic webinar for you scheduled. We're going to be hearing about the Data Puzzle Project, integrating authentic data and ambitious science teaching practices to help students make sense of phenomena. So I'm here with my colleagues from the NGSS ESS Working Group, Ed Robeck from AGI, and Missy Holzer representing the National Earth Science Teachers Association. And boy, I have to change that slide. John McDerris is not with us today from CERC. We have Ashley with us back there in the background, doing all the hard work on tech for us. Thank you, Ashley, for supporting us today and leading up to this webinar. So we have two presenters joining us today. We have Melissa Bratton and Jonathan Griffith, both from series out at the University of Colorado Boulder. We'll be turning things over to them in just a few minutes. They'll have about 45 minutes for their presentation. During that time, we really encourage you to use that chat box. It's not a question box only, it's a chat box. So please feel free during the presentation to drop in your thoughts and your ideas. What comes up for you as you're hearing from them, and of course put those questions in there too. We will be harvesting questions, thoughts, and ideas from that chat box throughout the course of this, and we will have time at the end to pose those questions to our presenters. And then at the very end, we'll give you the link again to the post-webinar survey. Please do complete that for us. We really appreciate having your feedback and any ideas that you might be sharing with us for future presentations that would be important to your work. So please make sure that you hang around to do that post-webinar survey. Also, if you want to receive a certificate of attendance, the only way to get that is through completing that survey. A couple quick announcements here. We do have one upcoming webinar that we can tell you about right now, and that will be on April 20th. And I'm really excited about this one as well. This is going to be from the infamous PhET group, the PhET simulations. So we'll be hearing from Rebecca Vieira and some others there about integrating earth and space science concepts into high school physics and physical science courses using those PhET simulations. And then if you happen to miss out on any of our webinars, or you just want to go back and get a refresher, please visit the AGI YouTube channel. There is a playlist there with all of our webinars throughout the entire this is our 8th season, so all 8 seasons of those webinars. So at this point, I'm going to go ahead and turn things over to our presenters. I will stop sharing and pass the screen over to them. And thank you for presenting for us today. We're excited to hear from you. Take it away.
Great. Thanks, Aida, and welcome all, and thanks for being here with us today. Melissa and I are so excited to be at this point where we're able to share data puzzles with you. Just so for those of you that may not be familiar with this resource, this is a resource that combines classroom-friendly data sets with the research-backed instructional practices of ambitious science teaching to help students make sense of phenomena. And this really feels like our big reveal. We've been working really hard the last year or so to refine our instructional framework and develop new resources and get them pilot tested. So it's really exciting to be at this point with you all. And our goal today is to describe the instructional framework and collaboratively engage with that framework in the context of one of our data puzzle resources called the tipping point. And so who am I? At my core, I'm John Griffith, and at my core, I'm an anxious new dad, but my day job is as a curriculum developer for the Cooperative Institute for Research in Environmental Sciences as part of the education and outreach team. In my past life, I was a climate scientist, then a middle school science teacher. And so this job, getting to work with scientists to bring resources into classroom, is really a dream come true for me. And I'm the lead developer of data puzzles. I'm the talking head for this a hugely collaborative effort. Want to acknowledge the work that my supervisor, Dr. Anna Gold, and Amy and Casey have done in making this possible, and would like to now give Melissa an opportunity to introduce herself.
Hi, everybody. I'm Melissa Bratton. I'm an associate professor in the School of Education. I am a professor focusing on STEM education and teacher education. And along with my co-authors, Mark Winchell and Jessica Thompson, I wrote the Ambitious Science Teaching Framework, which is also visible there as a book, and it's a website and the product of about 15 years of research alongside teachers. In my past life, I was a soil microbiologist and then a teacher I've taught every science from 5th grade up. And another person who is a big important collaborator for our data puzzles project is Dr. Carrie Wingert, who is also here at CU Boulder with me.
Great. And so not only are these data puzzles the product of lots of people putting lots of energy into it, but we also want to acknowledge those that we were really inspired by, and you'll see elements of their work in our work. So we want to acknowledge Liz and Melissa at Data Nuggets for their data analysis products. And they continue to put out great resources and are building extension tasks for those resources. We also want to acknowledge Kim Castens and Margie Turin and Missy Holzer for their work with Lamont Doherty creating geoscience data puzzles and published the 2010 book Earth Science Puzzle. So really great work that we're trying to build upon. And also funny that
I just want to give you a moment to read through these. We realize and recognize and honor that each of us is in a different place in our journey with the content of this book.
My apologies, I just muted that one, sorry.
Okay, great. So yeah, I want to acknowledge those resources and also FET, who I guess will be presenting next month. They've developed an amazing virtual teacher workshop framework and have worked closely with us to build one. We've just recently put a virtual workshop on our page, which we'll give you some time to explore in a little bit. So lots of great resources out there, and we're thankful to get to learn with and from these folks and others. I think that we'll skip this part because that's kind of been done. If you've yet to introduce yourself in the chat, please do. But like Aida was saying, we really want to encourage you to ask questions and share your thoughts and ideas in the chat. We really view this as an opportunity to learn with and from you. And we have a number of people monitoring that chat and keeping track of those ideas. So please use that during today's webinar. Today, what we're going to go through, we'll quickly talk about our story. How did series and ambitious science teaching come to be together? Melissa will give us an overview of her work with ambitious science teaching and developing those practices, and we'll give you some time to explore the Data Puzzles website and explore a Data Puzzles resource. And then together we'll collaboratively engage with ambitious science teaching practices in the context of one of our data puzzles called The Tipping Point. We'll highlight these virtual workshops that are recently online and some other opportunities coming soon, and then we'll have time for some questions at the end. And so we'll begin with our story, which actually begins in the Arctic. The inspiration for this work came as a result of my work with the 2019-2020 MOSAIC Arctic Research Expedition. It was one of the largest research expeditions ever conducted, with hundreds of scientists from more than 19 countries participating. And so this expedition began in September of 2019 with an icebreaker with about 100 scientists on board, set sail from Tromsø, Norway, north into the central Arctic in search of a flat piece of ice with which to attach itself to. And once attached, scientists deployed instruments across the ice to study processes and factors from the bottom of the ocean to miles up in the atmosphere, all with the goal of better understanding the changing Arctic climate system. So this research vessel, the scientists, these instruments drifted across the Arctic along transpolar currents for an entire year, studying these processes. And so my job was to tell the story of this expedition and connect the public to K-12 classrooms by developing resources. So we have a number of storyline curricula, virtual reality tours, among other things. But what kept coming up from teachers, both during the expedition and after the field portion was complete, is they wanted to engage with MOSAIC datasets. And so, given my position, having access to hundreds of scientists with lots of data and lots of compelling stories, we wanted to figure out how we could bring those data sets and those stories into classrooms using research-backed instructional practices. And that's where we recruited Melissa in to help us do that. And so the combination of, authentic classroom-friendly data sets with these instructional practices, that's our goal, that's our vision. And so Melissa really helped us with that. And so I'm going to turn that over to Melissa now to describe her work.
So John and Anna Gold at Series approached me for some help thinking about what kind of pedagogical framework could we put in the background while building some materials that teachers could use to access data from the MOSAIC project and from other Series affiliated scientists who have interesting data sets that could be useful for classrooms to study. And John and I realized that we had a connection because John used the ambitious science teaching framework as a teacher. So it became like a natural match for us to figure out, okay, how can we take the interesting phenomena and questions and data that are part of contemporary scientists' work and build it into materials, and now as we're working ahead on some virtual professional development series, build things that will be coherent with what teachers might already be doing in other storylined curricula or curricula that are aiming at the NGSS, and to make it be something that teachers might also be able to constantly work on their pedagogy as they are trying out some of these practices and trying out data puzzles in their classrooms. So I want to give a little overview of what the ambitious science teaching framework is. So John, if you can move me, thanks. The ambitious science teaching framework is a pedagogical framework. It exists as both a book and a website. And it's a framework that's made up of principles, practices, and tools that support meaningful and equitable science education around 4 clusters of pedagogical practices that you can see on the diagram. It looks like a cycle, but in reality, teaching is more complicated than that. So it's often that teachers are like popping around between these 4 components of practice in order to build really meaningful learning experiences with kids. And this work came out of, as I mentioned earlier, about 15 years of research of me, Mark, and Jessica sitting in classrooms alongside teachers, trying to figure out where are they getting stuck? What could we build together to try to help teachers get unstuck in order to work on these 4 big things that we value in science education, of engaging with really important science ideas, not trivia, engaging kids' ideas as key resources for sense making, working with kids' ideas to support their ongoing changes and refinements to their thinking, and then pressing students to construct strong evidence-based explanations and models. And so we did this work alongside teachers and captured it in a book and a website. And I think of ambitious science teaching as kind of the mortar that helps teachers hold all the bricks together in their work. And what I mean by that is that every teacher, I remember it vividly myself in the classroom, you're handed a lot of bricks. So you're handed binders of instructional materials, you're handed certain district initiatives, there might be other kinds of tools that you're expected to be using in your classroom, and then you're also handed standards that you're expected to address. And those can feel disconnected and incoherent when you're teaching. And we built the ambitious science teaching framework to try to provide like the mortar that could glue those bricks together and help teachers organize their instruction to make science education really coherent. Coherent from the teacher's point of view and coherent from the learner's point of view. So we're not a curriculum, we're more like the glue that holds curriculum and every other kind of tool together for teachers. In data puzzles, this pops up like this. John, do you want to explain this part or you want me to do it?
Go for it.
Okay, so in data puzzles, where we're building like a little curriculum add-on that could be part of teachers teaching for 3 or 4 days, we're helping teachers think about ways that they could engage in all 4 of these clusters of practices while they are working through the data puzzle. So data puzzles have a similar structure no matter what the phenomenon is. They begin with an opening scenario, a discussion, and a chance for kids to really contribute their ideas and experiences in language, the eliciting students' ideas quadrant of this framework. The data puzzle also provides an opportunity through an interactive reading, some initial models and prediction making to try to anchor what we're getting ready to do in the data puzzle to a really important science idea so that these puzzles are not trivial. They're about something really big in science. Then there's an opportunity, the sort of core part of the data puzzle is to analyze data and identify a pattern and use those patterns to revise the predictions or models that learners made in the previous part of the data puzzle. And this is an opportunity with also some dialogue prompts to support some ongoing changes in thinking for kids. And ultimately, the data puzzle is part of an effort that a teacher could be making to compile evidence, to revise models and construct a good evidence-based explanation for a phenomenon. And data puzzles end with some prompts that help teachers and students dig a little deeper to what could this mean now that we have this, we figured out this data, what could this mean for our phenomenon that we're trying to figure out or for other phenomena that we're interested in.
Great. And so we thought that we might give you all a few minutes to kind of digest some of that and explore our website to see what it's all about. And so I wanted to give you a quick tour of the site before we send you there. The data puzzle site, the homepage looks like this. We've got a tab that describes the instructional framework, our collection of data puzzle resources, our one virtual workshop that we've put up this week, and with more to come, some tools and resources in our team. And so if we were to look at the tipping point, there are teacher guides, slide decks, student worksheets, answer keys, everything is here for you. And the teacher guides for these resources all look the same. There is some background information about the big science topics that will be explored in the resource. The first page also, we divided these data puzzles into parts, which reflect the ambitious science teaching parts and practices that Melissa just described, about how long those will take. The second page has connections to NGSS standards, a question that students are going to be investigating in the data puzzle, those materials, new vocab, and then the teacher guides are, those parts are explained in greater detail on pages 2, 3, or 3, 4, and maybe 5. We tried to create a comprehensive teacher guide, but that one that isn't so overwhelming that it may never be used. So we thought that, I'm not sure if this link has been popped in the chat yet. Data puzzles in the chat. Maybe I'll pop this timer up and we'll just be here for 5 minutes, give you some time to explore the page. And if you come up with questions as you explore, please post those and share those in the chat. All right, we'll see y'all in 5 minutes.
Right, I'd like to invite everybody to start making their way back in the next 20 seconds or so.
I'll go ahead and stop this before it starts ringing at us. And head back to the slide deck. So hopefully you got a chance to just dip your feet in there and get a sense for what's available to you through this website. Obviously, more than you could take in 5 minutes, but our collection consists of about 9 data puzzles that have explore topics related to Arctic amplification, the Arctic warming more rapidly than the rest of the world, the mega drought it's happening across the Western United States, mega fires, climate tipping points, which we'll explore here, and a couple of new data puzzles that are being piloted right now that are up related to wind and wind energy. And so we'll continue to build that library, but those are the ones available right now. We're really excited about them, as well as that virtual workshop that's up there, and we'll continue to build that out as well. So what we're going to do right now is dive into the tipping point data puzzle together and collaboratively engage with this resource and explore how these 4 ambitious science teaching practices are embedded and infused into this resource. And like Melissa was saying, all data puzzles start with the eliciting students' ideas practice. The goal with this practice is to bring out student ideas about an opening scenario that could be an image, a question, a video, or demonstration that has similarities to the science investigation that's going to be presented in the data puzzle. And so these student experiences, ideas, student language can be used by the facilitator, the teacher, as resources to help these students make sense of new complex science phenomena. For example, if we have a data puzzle about the Arctic, we don't want to start talking about the Arctic and specific data sets that are happening perhaps thousands of miles from where the students are. We want to connect the students to an idea, concept that they might be more familiar with, and then say, scientists are exploring something similar in this far off place. And so by bringing out those initial ideas and language from students, we can use those as resources throughout the data puzzle. This practice is not represented in the student worksheet. Teachers that we work with typically use it as either a warm-up prompt or a think, pair, share discussion. We've also had a number of teachers use whiteboards or large pieces of butcher paper where students collaboratively respond to the opening scenario. For the tipping point, the opening scenario asks students to consider this scenario. Every time you go to a doctor, the first thing that happens is you get your vital signs measured. This could be your heart rate, your blood pressure, your weight, your temperature, your height. These things are measured. And so why does that happen every time you go to the doctor's office? Why are doctors keeping track of that year after year? So you would pose that to students, give them an opportunity to discuss this, to jot it down in a notebook or on a whiteboard, and then have them share their thoughts and experiences if they feel comfortable with the rest of the class. Ultimately, we're trying to get students to think about doctors, physicians, nurse practitioners. I want to bring up PAs because my wife's a PA. Trying to keep these long-term trends in mind and why it might be important to see if things are changing. Tracking these long-term changes can help doctors identify potential problems, and kind of trying to make students then take this scenario and work their way to thinking about what the scientists in the data puzzle are investigating. We ask students then to imagine, what if you could take plants to a doctor? What kind of measurements do you think those doctors would want to take? And how might a doctor know if the plant was unhealthy? So making the connection, human vital signs, we're tracking changes over time. when we see like big changes, maybe there's something wrong. And that's the same with plant doctors, tracking changes in plants. If they saw big changes over time, what might be causing those changes? And that's exactly what Dr. Dan Doak, Bill, and Megan have been doing in Arctic and alpine and tundra ecosystems for the last 20 years. They've been studying the growth and survival of a particular type of plant called Moss campion across a broad geographic range. And they're particularly interested in measuring the survival, growth, and reproduction rates and how those may have been affected by temperature. And so hopefully you can see we're going from an experience students can relate to going to the doctor's office to maybe they have something they haven't thought about as much as scientists studying plants in alpine regions. And so we're trying to make that connection with the opening scenario. Before we dive into this interactive text, which Melissa will describe in just a moment, where we learn more about their work.
Can you go back one slide, John,
Yep.
for just a sec? Another big part of how an important value that we're trying to capture in data puzzles is that we also want to make it visible to kids and teachers, like how scientists do their science and who the scientists are. So we're trying to show, like, we ask our scientists to, like, can you take some photos while you're doing your work so that we can share, like, that in this case, Dan, Megan, and Bill go hiking and they take a backpack and they take tools like a ruler and a camera and they take photos and measurements while they're out walking. So we're trying to show kids like where the data actually come from, and that often the data that we're featuring don't require like black boxes and complicated technology. It's often like this kind of data where it's a scientist laying a ruler down and taking a photo and just doing that year after year in order to gather some data. So we're trying to feature a little bit about like how the science even happens so that the data sets aren't coming out of nowhere. They're coming from like a specific story of the scientist's work. Thanks, John. Can you click me ahead? Thank you. So on ambitious science teaching on our website, part of our tools, we also have a lot of resources that are linked, and we're signaling between the data puzzles website and the ambitious science teaching website to try to help teachers if they're trying to think about, like, I don't really know how I would elicit students' ideas in my classroom. Like, I don't really know what this routine could look like. We're trying to use data puzzles to drive people to go look at some resources that are available on ambitious science teaching. So we have lots of video collections on our website where we've captured examples from real classrooms of how this kind of practice can play out. We also have some lots of little like teacher tips and foothold practices that help teachers just with like if they're struggling to figure out one part of their practice, like how do I help kids become more fluent in using some vocabulary that they're grappling with, but I don't want to do it in a way that's like forcing some vocabulary when it doesn't feel, when kids don't seem quite ready to take on that new word. So these are just a couple of examples of some of the resources in ambitious science teaching on the website version that we're trying to use data puzzles to like help support some pedagogical work if that's something that teachers feel like they're ready to access. All right, click me ahead. Thanks. So the next part of every data puzzle is a section where we're helping teachers and students really locate the specific work that they're getting ready to do in the data puzzle to something that's a really important science idea. And one of the big things that we found in our ambitious science teaching research project was that often teachers we're trying to do almost like too much in the like towards the effort of trying to make everything be a new discovery, and that when teachers would clue kids in just in time to a little bit of information, that could make all the difference for kids' abilities to make sense of what they were doing. So we're trying to build this into data puzzles with just like a little bit of information in the form of just like a small text that could be used as a whole class read aloud or as like a close reading among individual students or small groups or pairs. Just a little bit of information to help kids get going on the big idea that's part of the data puzzle. And we call this thing the puzzle plot. So John, if you can click me to the puzzle plot, thanks. So the puzzle plot is just filling kids and teachers in on like, what are these scientists doing? Like when they climb up this mountain and they take these photos of this plant, what are they really doing? What science are they working on? What are they trying to figure out? How does this fit in with other questions that the scientists might be asking? And we provide some scaffolding for teachers and students to figure out what to do with this text. So they could be circling investigative question, underlining similarities between the reading and the opening scenarios, so that if a teacher wanted to ask that question of like, how is plant doctor kind of like when you go to your doctor? We have those things already underlined in the text so that kids can start talking back to the original setting of the data puzzle. And click me ahead, please. So in this case, this puzzle plot tells us some information about moss campion. So it tells us like that it's an alpine tundra plant and that it's a nursery plant. It helps us see the broad geographic range where this plant grows. And it points us in on what the scientists are actually studying, that they're trying to figure out some vital signs of this plant. And they care about that because a change in these vital signs might tell us something about environmental changes that are also taking place. So it's helping set up a conversation between kids and their teacher about, okay, if we know about these changes in moss campion, we can know more about A, B, and C about a changing climate. We can use moss campion data to help us infer something about a changing climate. These would be hard leaps for kids to make without a little bit of scaffolding in the form of some of the tools that come in the puzzle plot and some of the pedagogical work that we're trying to support by the links to ambitious science teaching. And we also include some specific prompts to the teacher to try to help teachers think about, like, this isn't just a worksheet that we want you to hand to kids and have them work on silently. We want this to be a pedagogical tool that you can use as part of a highly interactive classroom. So there's some prompts throughout the data puzzle to remind the teacher, like, this is a chance to like have everybody talk and make a connection as they're working through, and be prepared to share your thinking back to the whole class. All right, so in the student worksheet, the student sheet that you can download from data puzzles, that we also made these all as things that teachers can modify, like they're not locked in to a certain format. They can modify the tool itself. So in the data puzzle student facing materials, it has some prompts to ask kids to draw and describe how moss campion plants have adapted to their tundra environment, record the investigative question that they think the scientists are likely to be asking from what they've learned from the puzzle plot, and to start making a prediction based on the evidence in the text about, like, what do you think these scientists are likely to figure out? If they figure out their data, what are they likely to figure out about both moss campion and about a changing climate? And here's an example of what we see when kids work on a data puzzle. So we're learning things each time that we gather some student work. We're learning like how our scaffolding is making space for kids to include ideas, and how we might be limiting the ideas that kids are able to communicate. So for instance, like, we're seeing that kids aren't really understanding what kinds of things they could put on their model. So they ended up, in this case, just drawing a few dots, but we think we might have misled them because that's what we put in the key. So we're learning things that like this might be a place where we would change the scaffolding now and change it to support kids to draw a little bit differently. But this is also like a quick look for teachers to like walk around real fast and see, like, are kids ready to dig into the data, or are they still in a space where they need a little bit more support to figure out what are we even looking at when we look at moss campion reproduction?
Great. And so for this data puzzle, the investigative question has to do with like, how might temperature impact moss campion reproduction? And so this student has made a prediction about that question, how temperature may impact the reproduction rate of moss campion. And now after making that prediction, we're ready to go on to the next practice, supporting ongoing changes in thinking, where students are going to test that prediction against an authentic data set. And so really important to this step, before having students analyze a data set that they're maybe unfamiliar with, ask them to identify patterns. It's really important to talk about the graphs. One strategy Melissa outlines in her book and through observation is just calling attention to the extreme data, the high and low points, and asking students to have conversations about what that point might mean. What does that high point mean? What does that low point mean? Conversations about different colors on graphs. What do these mean? It's really important to have these conversations before sending students out to work on their data sets. With data puzzles, we encourage students to work either individually in pairs. We almost always prefer pairs to get students thinking and talking about the data together. And we also encourage teachers to use data analysis strategies that may be common practice and something their students are already familiar with. For example, the what I see, what it means strategy, WISWIM strategy. We encourage teachers to use some of the practices that are entrenched in their classroom to continue to support sense making as it comes to data analysis. So for the tipping point, the prompts that we have for these discussions about the data are in the slide deck. And so you can see the tipping point data set here on the right. We have the reproduction rate of moss campion on the y-axis, and July temperature on the x-axis. We use July temperatures because July temperatures are the warmest in the alpine region, and so that's kind of the threshold. Temperatures beyond that really can affect moss campion reproduction rates. So we ask students to consider, what temperatures were moss campion reproduction rates the highest, the lowest? Is it ever too hot or too cold for moss campion to reproduce? So these questions are really designed to support the scaffolding as students see and try to make sense of a new data set. They also were trying to call attention to some of the patterns. That question, is it ever too hot or too cold? Really trying to get students to think about that, and especially in the context of being a tipping point resource. So the scaffolding also comes in the form of the student questions. After having that discussion as a class, you can see the student worksheet screenshot here on the left. We have scaffolding in the form of questions and prompts to help students notice important points and trends, to try to help them connect data and explain what that data means, and then connect that data back to earlier predictions, kind of being able to revise their thinking as they gather new evidence. And so here is some student work example, that same student. We have them looking at describing data, these 3 different temperature ranges, 6 to 10 degrees Celsius, 10 to 16, and beyond 16. We have them describe patterns, create rules for their patterns, and then really try to put those patterns into context and ask them to revise and revisit their prediction for that investigative question. Melissa, do you want to add anything to this before we move on?
Nope, I'm gonna speed us up through our last practice so that we can
Got it.
make some space for questions at the end. So the last part of data puzzles ask kids to now draw upon what they've learned from analyzing the data that are, just one clue to being able to explain something that they are working on. So we, again, refer back to some ambitious science teaching tools and resources about constructing explanations. On the next slide, we have some ideas about some tools and resources for helping kids represent their ideas as different kinds of pictorial models, like by using timelines or like beginning, past, present, future ways of representing a phenomenon. And we provide teachers with a little idea about, for this data puzzle, what kind of representation could you have kids try to use to show how they're interpreting the change or the pattern that they're seeing in the data. So on this one, the change over time isn't about time, it's about 3 different conditions, like a low, medium, and higher temperature range. So having kids figure out, like, how could I show a change in the moss campion reproduction rate as it compares to this change in these 3 different temperature conditions, to try to help quickly assess, like, are kids making sense of the data pattern that they're seeing? Can they show it in another representation? And be able to understand, again, the relationship between moss campion reproduction and temperature. And then the final part of a data puzzle is called digging deeper, where we're asking kids and teachers to think about, well, what does this mean now that, like, we figured out this particular pattern about plant reproduction rate and temperature? What does this tell us? So could it tell us something about other organisms in this environment? Could it tell us something about other kinds of endangered plant species? Could it tell us something about the environment itself and inferences that we might be able to make about climate change? So the consequences can also, in some of the data puzzles, it also invites teachers and kids to think about, in your local area, what might you start to investigate, or what could you start to act on or become concerned about and work on in whatever habitat you're in, so that we're trying to prompt a little bit of, like, take this phenomenon and connect it to a phenomenon closer to home. So John, I'll let you wrap up by sharing what's coming up next, and then we should have some time to address some of the questions that are popping in.
Great, thanks, Melissa. So coming next, I've mentioned this a few times, we've got some virtual workshops that are currently under construction and more to be added to our website soon. I'm gonna drop a link to a different survey in just a moment. Really interested to hear, like, teachers, if they're going to complete a virtual teacher workshop, what are they most excited about receiving in terms of credit? Do they want a PD certificate? Do they want grad credit options? Are badges useful to them? So really wanting to figure out from teachers what would be useful for them if they complete this workshop. Like Melissa said, we're in classrooms right now filming to provide examples of how teachers are using data puzzles and what that looks like in the classroom. And then we'll be at NSTA, or I'll be at NSTA. We'll be presenting about data puzzles March 23rd, but would be happy to meet up and chat with folks at that event. That's what we have. Please email me directly if you'd like to learn more about data puzzles or have us chat with teachers or in your district. If you want to keep up with data puzzles, you can follow us on Twitter at SeriesEO or email me directly. But we're excited to continue to work with teachers to bring data puzzles and really just ambitious science teaching practices, good teaching practices into classrooms and make that the norm and routine. That's it for us.
John, there's a couple of questions in the chat. I've been paying attention while you've been talking.
Great.
So one question, these are very specific to the data, and since that's the part that you have paid attention to the most, I want to raise those questions. So one question is about, what are the units on the plant on moss campion reproduction rate?
That's a great question. I'd have to look back in the student worksheet, but it's a flux rate. And so we didn't include those units in the y-axis, but they are included in that student worksheet, and I can't remember them off the top of my head, but that's a great question.
And then another similar question was about, I'm scrolling up. How did you get 6 temperature range bars from 4 field areas? I'm guessing that maybe 2 sites covered an altitude range.
There were, yeah, those are great questions. There were, they were like latitudinal ranges and altitudinal ranges. So my guess, I can't remember again off the top of my head. I'd have to just look at the student worksheet. The units and the temperature ranges are described in the description of that graph. But off the top of my head, I can't recall.
And then I'm seeing a question about, I'm curious about creating a data puzzle on other phenomena and other data sets. Do you have a favorite framework tool for designing data puzzles? I've poked around and found a few things. Curious what you love. We've thought about making data puzzles into sort of a template, but we haven't figured out exactly how to do that yet. But we are really interested in what other phenomena or topics or data sets you might like to see represented, because there's so many scientists affiliated with CERES. We can probably find somebody who is exploring topics and phenomena that you might be interested in. And a big part of John's collaboration through CERES is talking with scientists and trying to help them turn their data set into a data puzzle.
So I will say we have found that the best stories for these data puzzles are change over time stories or compare and contrast stories. Trying to bring in too many science concepts at once into kind of we're trying to create more concise products here can be a little bit too much. So change over time, compare, contrast stories seem to be most effective for this framework.
I'm seeing Kim's hand is up. Please ask your question, Kim.
Hi, I am always thrilled to see people having students work with authentic data. And I think this is an interesting data set that you've chosen. I also like the idea of introducing, doctors to collect your vital signs over, the 13 years you've been alive or whatever. But the puzzle doesn't actually make use of the fact that these scientists have been working in this field area for 20 years. And they're, so in other words, the students are not seeing any data that have a time series in them. So I'm wondering about the sort of connection point between the idea that we can learn important things by monitoring something over time, be it, atmospheric carbon dioxide or, river height or whatever. There's lots of things that earth scientists do where they observe things over time. And from the patterns of behavior over time, they make inferences about the process. So that's a great setup, but the puzzle doesn't actually do that. The puzzle has the independent variable d temperature, which isn't a change over time. So I think it's kind of a missed opportunity there. And my second question is, I'm wondering sort of how your collaborating scientists feel about the inferences that the students are making. So, they are surely acutely aware that there's many other factors that are in play here, like, altitude, for example, to pick something that came up in the questions, and whatever organisms may feed or not feed on these organisms. I mean, there's a lot more going on than just July temperature, rainfall, and many other factors are at play. And to have the students write a conclusion that July temperature is the driver of this reproductive rate change, is quite different than the kind of conclusion that the scientists would be making from their work. So I'm just wondering what kind of reaction you get from the scientists about simplifying so much.
Yeah, I would say in this case, these data sets these scientists produced this graph for us. And so we were looking at their work and the complexity of the graphs they were producing and in the papers that they published. And so we worked with them to look at their data set and to curate a data set to tell a story, in this case the story of the tipping point, given that as temperatures rise we see this increase in reproduction rate up to a certain point, beyond which it declines pretty dramatically. And so we're looking for a curated data set that was accessible to, we felt was accessible to middle and high school students. And so, yeah, these particular graphs are and data sets are curated by the scientists, not us.
Yeah, no, I'm absolutely confident you're using accurate data that you've gotten from the scientists. But maybe at the digging, maybe you could alleviate my worry on this point by at the digging deeper step, just have the students brainstorm about, like what other factors could possibly be influencing reproductive rate other than the one thing that we've put in our hypothesis, July temperature.
Great, yeah, thanks, Kim.
Well, thank you so much, Melissa and John. Those were wonderful comments and a wonderful introduction to data puzzles. We very much appreciate it. And I'm looking forward to being able to dive in and dig more deeply into a whole bunch of them, because I've already put notes on my note paper here that I want to look at a few of those. So thank you so much. I'm sure everyone else is in the same barrel there. Just to kind of put a wrap on a few things here, reminder that we do have an upcoming webinar on April 20th. It will feature Rebecca Vieira, who works with the PhET simulation team. And so we'll be bringing PhETs to you for the first time on the NGSS ESS working group webinar series. We're happy to do that. And also, if you've missed out on any of our webinars, want to go back a couple of days, this one will be up there. If you want to go back and revisit some of the conversations here, please do that on the AGI YouTube channel that will be available to you. We do have our survey, our post-webinar survey. We would love for you to fill that out. If one of my colleagues could please drop that, thank you very much. The link is in the chat box. Please take a couple of minutes here at the end and fill that out for us. And I am really excited to announce that we have a new page coming out very soon, within the next couple of days, on the NAGT website, brought to you by the NGSS ESS Working Group. Missy and Ed and I have been working very hard to bring you a listing of professional development opportunities for K-12 teachers. So if you are a teacher and you are looking for professional development opportunities, watch your inbox. We'll be sending out the link to that soon. If you are an organization or an institution that offers professional development to teachers, please make sure that you reach out to one of us if you haven't already gotten the link to fill out to get your offerings listed there. We would love to have a very comprehensive list so that we can all take advantage of those opportunities. So please be watching for that. On behalf of NAGT, one of the 3 sponsoring organizations of this group, we do offer webinars just about every week of the entire year. That's lots of webinars throughout the year. Please join us for those webinars and for many other member benefits at NAGT. I'm going to turn things over to Missy, who will tell you about the National Earth Science Teachers Association. Missy.
Hi, everybody, and thanks so much for Melissa and John for a wonderful webinar today. NEST is National Earth Science Teachers Association. Our foci are K-12 educators as well as those who prepare them. Please join us. We have a quarterly journal called The Earth Scientist. We have monthly e-news, and coming up real soon, a webinar next month. And actually, we have a workshop this weekend on astronomy content. So hope you can join us.
Ed, please say something about AGI.
Very quickly, AGI is a federation of member societies having to do with all aspects of the geosciences. I invite you to take a look at our website, which I've dropped into the chat, and especially things such as the resources that we have for Science Week and the Education Geosource searchable database of resources for teachers as well is there. Feel free to reach out to me and to my colleagues. And thank you very much for being here. And thank you very much to our presenters.
Just quickly to wrap things up here again, thank you to our presenters today for a wonderful introduction to data puzzles. And also thank you to Ashley Carlson for working the behind the scenes tech for us. We appreciate your support, Ashley. Thanks very much, everyone. Have a great rest of your afternoon.